3D printing is a fun and educational activity for kids. It can allow them to create physical objects from digital designs and can help them develop skills in design, problem solving, and critical thinking. By using 3D printing, students can collaborate with peers in assigned projects. In group projects, students learn from each other's perspectives and their different working styles. 3D printing also encourages students to use the feedback provided and enhance results. This presentation investigates the need for STEM education and different pedagogical approaches for the implementation of 3D printing within this field. In order to provide students with the training required to meet the substantial and diverse challenges of the 21st century, effective programs in engineering, science, and technology must continue to take the lead in developing high-impact educational practices. Increasing in critical thinking and evaluation often leads to success in multiple fields. A study conducted oversaw student collaboration in STEM-based science, cooperation, creativity, and thinking abilities. Other academic resources have mirrored the importance of STEM education as it has shown to increase asymmetric transferability of content knowledge across disciplines, in addition to increase inquiry, investigation, and analysis. Among the results of PISA 2015, it was reported that Australia, Canada, Ireland, Portugal, Singapore, and the United Kingdom were high performers in science. The 15-year-old students in these countries held strong beliefs about the value of scientific inquiry, and a larger than average proportion of students expect to work in science-related occupations later in life. 3D printing is a type of additive manufacturing that uses material to build upon layers into 3D objects. Printers come in all different shapes and sizes and can be configured in various ways depending on end results. 3D printing offers a way for students to truly connect with the subject matter by physically manipulating ready-to-produce teaching aids or design tools themselves. According to Bates in the second edition of Teaching in the Digital Age, the interplay between art and science of teaching supports students' level of judgment and decision making. This technology is applicable to this concept as it invites students to be creative, to come to the forefront of scientific investigation. This technology also provides evidence for student learning from which teachers can adapt their approach to subsequent lessons. Students can use this technology creatively in order to support interactive inquiry-based learning. The PICRAT matrix can be used by educators to investigate the use of technology and the long-term impact it has on student learning. This technology extends traditional means of lesson delivery in that it transforms lessons from simple question and answer type formatting into an interactive experience with the opportunity to extend into creative thinking. Synthesizing unique codes for specific tools to be printed is an example of how this technology can be extended across multiple inquiry-based skills. A study from Ye and Associates investigated the impact of this technology in human biology lessons. They found that the students who were able to compare more physical components of cardiac and abdominal anatomy scored significantly higher than subsequent assessments when compared against conventional groups of students. Scores represented advantages in some response time and accuracy. Therefore, 3D printers are situated in the interactive amplification category as they improve student outcomes through interactive means. Moreover, it can be argued that this technology has the capacity to transform lessons into a more creative sense, as students can be provided with the opportunity to create their own software to support their inquiry-based problem-solving skills. 3D printers amplify student learning by providing a unique way of engaging students in addition to the implication of physical resources to support lesson content. This technology supports the productivity of lessons as students are able to interact with the technology passively or actively, therefore providing a means of differentiation. Students and teachers use 3D printers to build classroom resources and furthermore construct artifacts which allow for physical interaction with complex ideas. An example of this in action could see students creating their own anatomical model in relation to their own area of interest in human biology. Other examples include synthesis of artifacts which model microscopic components of a given topic. A successive approximation model can be used to show how 3D printers can be applied in the classroom. During the preparation phase, students are able to determine how they can use this technology to support their chosen goals. They are able to access information and plan for optimal outcomes. Students need to be critical and use analysis to identify strengths and weaknesses of applying this technology. During the design phase, students can decide how they wish to use this technology. This is where students can use their creativity to construct their own device, or conversely, collaborate with peers, gather information from other resources, or adopt existing scaffolds which aim to support their deciphered goal. This phase allows students to draft and brainstorm different approaches in order to address outcomes and furthermore select the strongest approach. Trial and error are common themes of experience throughout this phase and support students' justification of their approach, therefore encouraging students to engage in higher order thinking. This process can be repeated when creating, reviewing, and revising different scaffolds. It is important to consider the safety when using this technology. The use of different filaments at different temperatures and different compositions can pose safety restraints. Heat is a consideration which is often applied when using this technology. These machines operate at temperatures of 190 to 260 degrees Celsius in order to melt plastics and correct consistencies. This is a burns risk. Mechanical risks and moving parts, including stepper pulleys, threaded rods, carriages, and small fans, with the use of interlocking systems to stop printing when the closed seal is open, ensure that these machines are used safely. Additionally, the toxic emissions are a product of thermal processing of thermoplastics. There are a number of substances which can be emitted and cause harm over time. Skin and inhalation are means by which these substances can cause harm. Therefore, PPE and ventilation is highly encouraged when operating these technologies. 3D printers are internet connected and openly sourced, meaning the kinds of objects that can be printed are limitless. This does not come without risk. A consequence of having such endless limitation is that there is a possibility of having confidential data accessed from third parties. This data may take the form of software codes or schematics. Software hacking poses a threat to the end product that is being printed. A 2016 study highlighted the availability for hackers to manipulate production and impair the overall quality of printed objects. Throughout a study, an identical drone propeller was created with microscopic changes which caused functions of the blades to fail. A breach in privacy ended with consequential outcomes on the grand scheme of things that may cause harm to individuals or communities at large. There are many ways by which 3D printers can be implemented in the classroom. As science concepts can often investigate intangible components, 3D printers offer students the opportunity to physically interact with components related to the content being delivered. An example of this was previously investigated by Yee and Associates, as the students were able to investigate anatomical structures by printing and handling different organisms. 3D printing offers a way for students to truly connect to the subject matter by physically manipulating ready printed teaching aids or by designing tools themselves. This technology also provides students with skills required for the future. It supports hands-on learning, ignites creativity, teaches problem-solving skills, and creates opportunities for integrating science, engineering, technology, mathematics, and other disciplines.